So in this video, I'm going to be going through the summer 2023 Edexcel paper 1 for A-level maths, which is the pure papers. Up until very recently, I said that I wouldn't be going through past papers because of the potential copyright infringement that comes with that. The exam papers as produced by Edexcel, by AQA, by OCR are owned by their copyright. So they have full copyright over those. It turns out that some exam boards are much more kind of like liberal with whether they allow people to go through their papers or not. So I'm not going to name any names, but I know that YouTube channels in the past have come a cropper from this and have had copyright strikes against them. So that's certainly not something that I wanted to do. So what I did was I messaged Edexcel, it said what I wanted to do, and they replied saying that they were happy with that. So I'm just glad that now I've got something in writing that I can kind of fall back on. The only other thing you should know as I'm working through this paper is that I don't teach Edexcel A-level maths. I teach AQA. The content is pretty much the same. I think there are going to be probably a couple of points in here where I'll be just double checking that I've got all the marks from the mark scheme, because I'm so used to working through AQA papers and questions. I haven't worked through all Edexcel questions, exam papers before. So a lot of this will kind of like, the questions themselves will be new. I've never worked through this paper before. The thing is that my brain, at least at the beginning, will be very much AQA. What would AQA be wanting? What would AQA be looking for? Okay, so bear with me as I kind of get used to Edexcel in working through their papers. And hopefully in time I can make more of these and progressively work through, and hopefully you'll find them useful. And we'll crack on. Okay, so this is question number 1. Find the integral of x to the half times 2x take away 5 over 3 dx, writing each term in its simplest form. Okay, so I'm going to make a choice here. I'm going to factor the 1/3 outside of the integral. Now, as I said, that is a choice. You can leave it inside if you like. It's really up to you. So I'm going to bring the 1/3 outside. What I'm then going to do is I'm going to expand the bracket. So we've got the x to the half times by the 2x. So that's going to get me 2x to the power of 3 halves. And I'm going to pop this in a bracket. Take away 5 lots of x to the half dx. Okay, so leave the third out the front. Now we're going to integrate each of our terms. So we just need to add 1 to the power, so 2x to the 5 halves, and then divide by the new power. Same here, add 1 to the power, so 3 halves, divide by the new power, 3 halves. And then we're going to have a plus c constant of integration on the end. Now, some of you might go, well, should we have the plus c inside the bracket or outside the bracket? It doesn't really matter. You don't really want to write 1/3 c at the end. Just write c. 1/3 of a constant is a constant. So now we just need to simplify this. Now, don't forget, we're going to multiply by that third as well. So we have 2x to the 5 halves over 5 halves. If you're dividing by 5 halves, that's the same as multiplying by 2/5. So we've got 2 lots of 2/5, so 4/5 times by a third is 4/15. So 4/15 x to the 5 halves. Then we've got 5 over 3 halves. So 5 divided by 3 halves is the same as 5 times 2/3. So that's 10/3. And don't forget, we've got the third on the outside as well. So that's 10/9. So take away 10/9 x to the 3/2 plus c. And of course, when dealing with those fractions, don't forget to check everything on your calculator as you go. Otherwise, it's quite easy to make a mistake. The only issue I could see with factoring that third out is that you forget to multiply through by a third. Maybe you won't forget the first time, so you might not forget to multiply by a third when you're multiplying a third by the 2x to the 5/2 over 5/2, but you might forget to include the third when you're multiplying it by the 5 over 3/2. Okay, so be a little bit careful, check your working. So this is question number 2. Big bold. In this question, you must show all stages of your working. Solutions relying entirely on calculated technology are not acceptable, we have been told. Okay, so f of x is equal to 4x cubed plus 5x squared, take away 10x plus 4a, where x is a real number. Where a is a positive constant, that's bound to come back to us at some point. Given x take away a is a factor of f of x, part A, show that a, 4a squared plus 5a, take away 6 equals 0, and that's for 2 marks. Okay, so part A then. Given that x take away a is a factor of f of x, so f of a is equal to 0. So if we substitute a into f, 4a cubed plus 5a squared, take away 10a, plus 4a is equal to 0. Okay, so we can simplify that a bit, can't we? Because we've got the take away 10a plus the 4a. So 4a cubed plus 5a squared minus 10a plus 4a is minus 6a equals 0. And then we can factor the a out. Ooh, went a bit too early there. There we go. Take away 6 is equal to 0. That's what we wanted, so as required. Lovely. So part B, part 1. Hence, find the value of a. Well, we've got this cubic equation that has been part factorised here, so either a is 0 or that quadratic is 0. Okay, so let's put it into the calculator's quadratic solver. Let's see what we get. So 4, 5 minus 6. So we have 3/4 and minus 2. So let's do an intermediate step here of factorising it then. Because we've got the 3/4, that means we're going to have a bracket of 4a take away 3. And we've got minus 2, so a plus 2 is equal to 0. So a equals 3/4, or a is equal to negative 2. But remember, a was a positive constant. Okay, so as a is greater than 0, we must have a is equal to 3/4 only. So it can't be 0, it can't be negative 2. 3/4 is our only answer. Okay, so part 2. Hence, use algebra to find the exact solutions of the equation f of x equals 3. Well, f of x was 4x cubed plus 5x squared take away 10x plus 4a. Now, we know what a is. It's 3/4. 4 lots of that is 3, so plus 3. And we're putting that equal to 3. Okay, so we now need to solve this equation. So we can subtract 3 from both sides. So 4x cubed plus 5x squared take away 10x is equal to 0. And I'm going to not jump straight to my cubic solver because I can see that I can factor x out here. If there is an algebraic step that I can show, I really do need to show it. That's why that bit in bold at the start, why there was that bit in bold. So I'm going to factor the x out. Like so. So that implies that x is 0, or this quadratic is 0. Okay, so I'm now going to go to my calculator and solve that quadratic. So we have 4, 5, and negative 10. Oh, nice numbers as always for Edexcel. So we have x equals minus 5 plus or minus the square root of 185 over 8. Okay, and so we have either x is 0 or x is either of those two solutions. Now you might be wondering, should I have shown an algebraic method to get to there, get these solutions there? Well, essentially I could have just done that by using the quadratic formula, right? So minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I didn't really need to show kind of any other algebraic step because I am expected to know the quadratic formula. So that's our question 2. So this is question number 3. Relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k. The point B has position vector 2i plus 4j plus ak, where a is a positive integer. Part A, show that the length of OA is the square root of 38. Okay, so part A. So the length of OA is found by using 3D Pythagoras. So because we've got 5i plus 3j plus 2k, that's going to be the square root of 5 squared plus 3 squared plus 2 squared, square rooted. So that's 25 plus 9 plus 4. Now 25 plus 9, 34, add the 4 is 38, so square root 38, as required. Okay, part B. Find the smallest value of A for which the length of OB is greater than the length of OA. Now, the length of OB is going to be the square root of 2 squared plus 4 squared plus a squared. And that's going to be greater than the length of OA, which is root 38. So 2 squared plus 4 squared, 4 plus 16, so 20. So we've got a squared plus 20, square rooted, is greater than root 38. So if that's the case, we can remove the square roots. We can square both sides essentially. A squared plus 20 is greater than 38. So subtracting 20 from both sides, a squared is going to have to be greater than 18. Now, previously in the question, you were told a is a positive integer. So this is the key bit here. So if a is a positive integer and a squared needs to be greater than 18, and we need to find the smallest value of a for which that's true, then if a was equal to 3, for example, then you'd have 3 squared is 9, which is not greater than 18. If a was 4, then 4 squared would be 16, which is not greater than 18. A equals 5, well, 5 squared is 25, which is greater than 18. Okay, so a equals 5. And that's our answer for part B. So this is question number 4. Big bold at the start. In this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So again, we have been told. So the curve C has equation y equals f of x, where x belongs to the real numbers. Given that f prime of x is equal to 2x plus a half cosine x, and the curve has a stationary point with x coordinate alpha, and alpha is small, use the small angle approximation for cosine x to estimate the value of alpha to 3 decimal places. Okay, so part A then. So we have been given f prime of x. We know that stationary points exist when f prime of x is 0. Now, we know that there is a stationary point when the x coordinate is alpha, when x equals alpha. We're told that alpha is small, so 2 alpha plus 1/2 cosine of alpha will be equal to 0. Okay, so we can replace the cosine alpha with the small angle approximation that's in the formula booklet, which is 1 take away x squared over 2. So 1 take away alpha squared over 2. And that's going to be equal to 0. So 2 alpha plus a half take away alpha squared over 4 will be equal to 0. So if I move everything onto one side of the equation and multiply through by 4 as well, we're going to get alpha squared. Multiplying through by 4, we're going to get 8 alpha, so take away 8 alpha. We're going to get 2, so take away 2. And now we have a quadratic in alpha. So let's plug that into the quadratic solver. So 1, take away 8, take away 2. And we get alpha is 4 plus or minus 3 root 2. So alpha is equal to 8.24264, etc., or minus 0.24264, etc. So alpha is small, so 8.24264, that's not small, whereas the minus 0.24264 is. Alpha is small, so alpha equals minus 0.24, and we need it to 3 decimal places, so 243 to 3 decimal places. Okay. Part B. Find the equation of the point P, 0, 3, lies on C. Find the equation of the tangent to the curve at P, giving your answer in the form y equals mx plus c, where m and c are constants to be found. Okay, well, let's substitute in the point into f prime. So f prime of 0 is equal to 2 lots of 0 plus a half cosine of 0. Well, 2 lots of 0 is obviously 0. Cosine of 0 is 1, so that's just going to be 1/2. So your tangent, seeing as we know the point that it goes through is 0, 3, will be y take away 3 is equal to m, which is a half, x take away 0. So I'm using y take away y1 is equal to m, x take away x1. Now, seeing as P is 0, 3, you already know what plus C is going to be, right? It's 3. So y equals 1/2 x plus 3. And that's the equation of the tangent in the form that they wanted. So this is question number 5. A continuous curve has equation y equals f of x. The table shows corresponding values of x and y for this curve, where a and b are constants. The trapezium rule is used with all the y values in the table to find an approximate area under the curve between x equals 3 and x equals 4. Given that this area is 17.59, show that a plus 2b is equal to 51. Okay, So, if we're using the trapezium rule, we know the result is 17.59. That's 1/2 times h, which is the width of the strip. So if you check the x values, you can see that they're going up in 0.2s. So that's the width of the strip. Times by the first y value, which is a, okay, so that one, plus the last, which is 13.5, plus 2 lots of the rest, so 16.8, plus b, plus 20.2, plus 18.7. Close the brackets. Okay, so 1/2 times 0.2 is 1/10. So if I multiply both sides by 10, we get 175.9. We've got the a and the 13.5. And inside that bracket, we've got b plus 16.8 plus 20.2 plus 18.7. So 55.7. So 175.9, we have a plus 2b plus 13.5 plus 2 lots of 55.7. So it's 124.9. So a plus 2b is equal to 175.9, take away 124.9, which is 51. And that's what I wanted, so as required. Lovely. Okay, part B. Given also that the sum of all the y values in the table is 97.2, find the value of a and the value of b. Okay, so we know that all the y values add up to 97.2, so a plus 16.8 plus b plus 20.2 plus 18.7 plus 13.5. So a plus b is going to be equal to, so 16.8 plus 20.2 plus 18.7 plus 13.5. So that's 69.2, so 97.2, take away that is 28. Okay, so we now have two equations with two unknowns. So let's plug those into the simultaneous equation solver on your calculator. Right, so 1, 2, 51, 1, 1, 28. So A is 5 and B is 23. And so there we are. So this is question number 6. We've been given A is log base 2 of x and B is log base 2 of x plus 8. Express in terms of A and or B. So part A, log base 2 of root x. Okay, well, root x we can write as x to the half. And then we can use the power rule to bring the half down to the front of the logarithm. So if log base 2 of x is a, then we've got a half of a. So we're done, okay? Right, let's go to part B. We have log base 2 of x squared plus 8x. Now that's looking like something we can factorise, right? So log base 2 of x plus 8. So we can break that apart into a sum of logarithms. So log base 2 of x plus log base 2 of x plus 8. And they just so happen to be a plus b. Okay? Right, last one. We have log base 2 of 8 plus 64 over x. Now, what can we do with that? Well, let's write it as a single fraction. So 8x plus 64 over x. because now that I've done that, I can use the quotient rule to bring those apart and write it as a subtraction of logarithms. And that's good because I've got the log base 2 of x, which I know is a. Now, this other bit, if we factor the 8 out, okay, this is looking good. And then I could use the product rule to bring those apart. Okay, and log base 2 of 8, we know that's 3, because 2 cubed is 8. So that's 3. The log base 2 of x plus 8 was b, and the log base 2 of x was a. So 3 plus b, take away a, is our answer. So this is question number 7. The function f is defined by f of x is equal to 3 plus the square root of x take away 2, where x belongs to the real numbers and x is greater than 2. Part A, state the range of f. Okay, so if we were to substitute in 2, we would get 3 plus the square root of 0, so just 3. So that means that if x is greater than 2, then f of x will be greater than 3. So f of x is such that f of x is a real number where f of x is greater than 3. Okay, so that's writing in set notation. You'll be perfectly fine with just writing f of x is greater than 3. Okay, part B. As is Edexcel, okay? Part B, find the inverse function of f. So first thing you want to do is you want to replace the fx with y, so 3 plus the square root of x take away 2. And then we want to swap the x's and y's. So x is equal to 3 plus the square root of y take away 2. That reflects in the line y equals x. And now we rearrange this to make y the subject. So, subtract 3 from both sides. Okay. And then we can square both sides. So, x take away 3 squared is equal to y take away 2. So, y is equal to 2 plus x take away 3 squared. Now we don't want to leave it there because we want to write it as f minus 1 of x is equal to 2 plus x take away 3 squared. And because we've introduced a new function, we should also write down its domain, which of course will be the range of the original function. So x is a real number greater than 3. Okay, so part C. The function g is defined by g of x is 15 over x take away 3, where x is a real number, where x is not equal to 3. Find gf of 6. Gf of 6. Okay, so first of all I need to substitute 6 into f. So that's 3 plus the square root of 6 take away 2. So that's 3 plus the square root of 4. So that's 3 plus 2, so 5. So now substitute 5 into g. So that's 15 over 5 take away 3, which is 15 halves. Okay, part D. Find the exact value of the constant a for which f of a squared plus 2 is g of a. Okay, so let's substitute a squared plus 2 into f. So that would be 3 plus the square root of a squared plus 2 take away 2. So I've substituted a squared plus 2 into f. And that's got to be equal to substituting a into g, so 15 over a take away 3. So we have 3 plus, now 2 take away 2 is obviously 0, so square root of a squared is a, and that's got to be equal to 15 over a take away 3. So that's a plus 3, if I multiply it by the a minus 3, times a minus 3 is equal to 15. So that's the difference of two squares. A squared take away 9 is 15. So a squared is 24. So a would be plus or minus the square root of 24, which is 2 root 6. Now, the question says find the exact value of the constant a, and I've got two values. So when you're doing these functions range domain questions, keep an eye out for these types of problems where it's likely that one of the answers doesn't work. So why wouldn't one of these two answers work? So f of a squared plus 2, you're substituting in something that's definitely greater than 2 into f, so that seems fine, equals g of a. So it must have something to do with something that's come before. So it must have something to do with that range. We found the range in part A. So if I substitute a into g, so if, let's say a is minus 2 at 6, g of minus 2 at 6 is equal to 15 over minus 2 root 6 take away 3. Okay, but that's negative. And we know that the range of f is greater than 3. So how can you have substituting in a value which we know gives a value that's greater than 3, and on the right hand side is a negative value? Okay, so that can't be the case. As f of a squared plus 2 must be greater than 3, a cannot be equal to minus 2 at 6. So a must be equal to 2 at 6 as the only answer. Okay, because when we substitute that in to g, so we double check that, 15 over, so g of 2 root 6 is 15 over 2 root 6, take away 3, which is 3 plus 2 root 6, which is clearly greater than 3. So a is equal to 2 root 6, and that works. So this is question number 8. We have a diagram that's not drawn accurately. Figure 1 shows the plan view of a stage. The plan view shows two congruent triangles, ABO and GFO, joined to a sector OCDEO of a circle, centre O, where angle COE is 2.3 radians, arc length CDE is 27.6 metres, AOG is a straight line of length 15 metres. So part A, show that OC is equal to 12 metres. So OC is that length there. Okay, so what we've been given is the arc length of a sector, and we know the angle. So for part A, we have the arc length is 27.6. So the arc length formula is theta times r. So that means we have 27.6 is equal to the angle 2.3 times r, the radius. So R is 27.6 divided by 2.3, which hopefully is 12. 27.6 divided by 2.3 is 12. So, therefore, OC equals 12 metres. I mean, it's 2 marks, so I think we've got to show everything now. Right, part B. Show that the size of angle AOB is 0.421 radians, correct to 3 decimal places. Right, let's see that then. So AOB is that angle there. So the whole thing, AOG, of course, straight line, would be pi. We could take away the 2.3, and then we could divide that by 2, okay, because they're congruent, so angle FOG must be the same as angle AOB, or GOF, okay? So, angle, oh, whoops, Daisy, let's try again. Angle, what was it? AOB, angle AOB is going to be equal to pi, take away the the 2.3 radians, so 2.3, and we're going to divide that by 2. So pi take away 2.3 divided by 2 is equal to 0.420796, etc. So that's 0.421 to 3 decimal places. Okay, so is that enough? One would hope so. You could increase that if you want, because I mean I'm very worried about, am I getting the 2 marks here, right? So, you know, you could say angle AOB is equal to pi take away your angle COE divided by 2, or some kind of exemplification there. It's a bit tricky, isn't it? Let's just make sure we're getting the full marks there, because attempts to subtract 2.3 from pi, yep, and then halved it. Yep, looks all good. Looks all good. Okay, let's just get rid of this bit for the moment. Okay, let's go on to part C. Given that the total length of the front of the stage, BCDEF, is 35 metres. Okay, so let's see, BCDEF. So that's all of it, isn't it? So BCDEF. So that's all of that. And that's 35 metres. Well, and that allows me to work out BC, doesn't it? So BC is equal to the 35 metres, take away that arc length, which was 27.6, and then divide that by 2. So 35, take away 27.6, divided by 2, is 3.7. Okay, so let's go back to the diagram. So that means that this bit here is 3.7, and that bit was, so CO was 12. So that means in total, OB is 15.7. So OB is 15.7. So what that allows me to do is that allows me to work, that's one side of the triangle. Now, the other side, because this is 15 meters, and these are congruent triangles, that means that AO is 7.5 meters. So AO is 7.5. So that means I can work out the area of that triangle. So we've got two of those triangles, so area is 2 lots of 1/2 times AB sine C. So that's 7.5 times by the 15.7 times sine of the angle. Now the angle was pi take away 2.3 over 2. Plus, okay, so that will work out that triangle and that triangle together. Now we need the area of the sector, which is 1/2 theta r squared. So that's 1/2 times 2.3 times 12 squared. Okay, so 2 times 1/2, so make sure your calculator's in radians here. 7.5 times 15.7 times sine of pi take away 2.3 over 2, and then plus 1/2 times 2.3 times 12 squared. So that's 213.69939, etc. So nearest square meter, so 214 square meters to the nearest square meter. Okay? This is question number 9. The first 3 terms of a geometric sequence are 3k plus 4, 12 take away 3k, k plus 16, where k is a constant. Part A, show that k satisfies the equation 3k squared take away 62k plus 40 equals 0. Okay, so it's a geometric sequence. So R, which is the common ratio, is equal to one term divided by the previous term. So that would be 12 take away 3k over 3k plus 4, and that would be exactly the same as k plus 16 over 12 take away 3k. So a term divided by its previous term. So going from there, we can multiply up by the 12 take away 3k and multiply up by the 3k plus 4. Okay, so let's expand these brackets. So we're going to have 9k squared. Then we're going to have 12 times 3 times 2, so 72. So take away 72k plus 144 is equal to 3k squared. Then we've got 3 times 16 plus 4, so 52k. And then 16 times 4, so 64. Let's subtract 3k squared from both sides. We'll subtract 52 from both sides. So it's minus 124. And then we've got 144 take away 64, so that's 80. So then if we divide through by 2, okay, as required. Okay, cool. Let's go on to part B. Given that the sequence converges, find the value of k, giving a reason for your answer. Okay, so what we want to do then is we want to solve this quadratic. So let's plug it into the quadratic solver. So 3 minus 62, 40. So 20, so k take away 20. And k is 2/3, so 3k minus 2 is 0. So I'm going to write it as factorised form. And then k equals 20, or k equals 2/3. Okay, so we really need to work out what the value of r is in each case. So if k equals 20, then r is going to be, well, 12 take away 3 lots of 20 over 3 lots of 20 plus 4. So 12 take away 3 lots of 20 over 3 lots of 20 plus 4 is minus 3/4. Okay. That's looking good. So I assume this is going to not work if k is equal to 2/3, because we want a value of r between -1 and 1 for it to converge. So 12 take away 3 lots of 2/3 over 3 lots of 2/3 plus 4. Three times 2/3 plus 4 is 5/3. So, converges implies that the modulus of r is less than 1. So, k equals 20 and r equals minus 3/4 is what we want. So then part 2, find the value of s infinity, the sum to infinity. So the sum to infinity formula is a over 1 minus r. So the first term in the sequence was 3k plus 4. So we now have our value of k. So 3 times 20 plus 4, that's a, over 1 take away r, which is minus 3/4. So 3 times 20 plus 4 over 1 plus 3/4. And that's 256 over 7. And that's my answer. This is question number 10. A circle C has equation x squared plus y squared plus 6kx take away 2ky plus 7 equals 0, where k is a constant. Find in terms of k the coordinates of the centre of C. Okay, so part A. Let's complete the square on the x's and y's. So we're going to have x and then half the 6k, so 3k. And we need to square that and take away the square of 3k. So take away 9k squared. Then we'll do the same with the y's. So y and then half the minus 2k, so minus k squared. Take away the k squared. And we've still got the plus 7. So x plus 3k squared plus y minus k squared. And then move everything over to the other side. So we'll have 10k squared take away 7. So part 1, looking for the centre. So the coordinates of the centre, minus 3k, k. And part 2, the radius will be the square root of 10k squared take away 7. Okay. The line with equation y equals 2x take away 1 intersects at C at 2 distinct points. Find the range of possible values of k. So you could substitute 2x take away 1 into what we've got here. I think I'm going to substitute it in here because I've already got bits expanded there. So let's do that. X squared plus, so the y is replaced with 2x take away 1, so 2x take away 1 squared plus 6kx take away 2k, 2x take away 1 plus 7 equals 0. Okay, so let's expand some brackets. X squared plus 4x squared take away 4x plus 1 plus 6kx, then expand this, so minus 4kx, then plus 2k, plus 7 is 0. So we've got 5x squared, we've got 6kx take away 4kx, so 2kx, we've got the minus 4x, now we've got the 2k, and we've got 1 plus 7, so 8 is equal to 0. So let's write that as 5x squared plus 2k minus 4x plus 2k plus 8 equals 0. Okay, so 2 distinct points. Implies that the discriminant of this quadratic is strictly positive. So, therefore, 2k minus 4 squared take away 4 lots of a times c must be positive. So we're going to need to expand the brackets here. So 4k squared take away 16k plus 16. Then we've got 4 times 5 times 2, so that's 40k. And then 20 times 8, so minus 160 is positive. So 4k squared minus 56k. Then we've got 16 take away 160. Is minus 144. And that's got to be positive. So can we divide that through by 4? So k squared take away 14k, and then 144 divided by 4 is 36. Okay, so let's plug that in the calculator. So 1 minus 14 minus 36. So we are getting 2 roots. So let's draw ourselves a little diagram. So we've got a quadratic that is going through at 7 take away root 85 and 7 plus root 85. This is on the k-axis. So where is that positive? Well, it's above the k-axis there and there. So k must be less than 7 take away root 85, or k is greater than 7 plus root 85. Okay, so you could write that in interval notation instead. So minus infinity, 7 take away root 85, not inclusive, union, 7 plus root 85 to infinity, all curved brackets. Okay? So this is question number 11. We have a graph of log 10v against t. The value v pounds of a mobile phone t months after it was bought is multiplied by v equals ab to the t, where a and b are constants. I'm just going to underline t months. Okay, so we know that we're in months here and v is in pounds. Okay. Figure 2 shows the linear relationship between log base 10v and t. The line passes through the point 0,3 and 2.79 as shown. Using these points, find the initial value of the phone. So that's when t is 0, and I know that log base 10 of v is 3 at that point. So, part A, we know that when t is 0, log base 10 of v is 3. So that means that v is 10 cubed, so £1,000. Okay, part B. Find a complete equation for v in terms of t, giving the exact value of a and giving the value of b to 3 significant figures. Okay, well, our axes are log base 10v and t. We've got this straight line. So one way of going about this is to say, well, log base 10 of v, that's your y, and that's equal to mx plus c. Now the gradient is going to be 2.79 take away 3 over 10 take away 0. And that's times t plus the y-intercept, which I can read from the graph, which is 3. So, log base 10 of v is equal to, so 2.79 take away 3 over 10 take away 0 is minus 0.021 t plus 3. So then, v is going to be 10 to the power of all of that, minus 0.021t plus 3. And then I can separate that out because that's 10 cubed times by 10 to the power of minus 0.021t. So I can write that as that. And now it's already in that form of ab to the t. So this implies that v is equal to 1,000 times by now 10 to the power of minus 0.021 is 0.95, and we want b to 3 significant figures, so 953 to the t. Okay? And so that is now in the correct form. So a is 1,000 and b is 0.953 to 3 sig fig. Right. Part C. Exactly 2 years after it was bought, the value of the phone was £320. Use this information to evaluate the reliability of the model. Okay, so if I substitute, now this would be 2 years. Right. I can see where a common error is going to be, because your instinct is probably substitute in t as 2. Let's just double check. T was in months, right? Not years. So 2 years would be 24 months. So t equals 24. Right. So 1,000 times by 0.953 to the power of 24 is 314 pounds and 94 pence to the nearest penny. And that's close to £320. So the model appears reliable. Okay? This is question number 12. Y equals sine x, where x is measured in radians. Use differentiation from first principles to show that dy by dx is cosine x. You may use without proof the formula for sine of a plus or minus b, and you may assume that as h tends to 0, sine of h over h tends to 1, and cosine of h, take away 1 over h, tends to 0. Okay, well, we will use those bits. Okay, so first of all, let f of x be sine x. So f of x plus h is sine of x plus h. So f prime of x, the derivative of f, is going to be equal to f of x plus h, so the limit as h tends to 0 of f of x plus h, so sine of x plus h, take away f of x, so sine x, divided by h. This is the limit as h tends to 0 of. Now, using the compound angle formula for sine of x plus h, that is sine of x cosine of h plus cosine of x sine of h. Then we're taking away the sine x that's already there, and we're dividing that all through by h. Okay, now this is the limit as h tends to 0 of, now let's group together the sine x's, so sine x and factorise cosine h, take away 1, plus, and we're going to write cosine x, and I'm going to open a bracket, sine of h, all over h. Okay, now I'm going to break this fraction apart, and I'm going to have the limit as h tends to 0 of sine x times by cosine h take away 1 all over h plus cosine x times sine of h all over h. And now I'm going to split the limit apart, okay, so that, and bring the sine x and the cosine x outside of the limit. So this is the sine x times by the limit as h tends to 0. Now, the reason why you can bring the sine x outside of the limit is because it's got nothing to do with the h. So just like with an integral, you can bring a multiplier out that's got nothing to do with the variable. This is the same kind of idea. So, cosine h take away 1 over h plus, oh, whoops, Daisy, I've forgotten my cosine x, haven't I? Plus cosine x, bring that outside, times by the limit as h tends to 0 of sine h over h. Now, the limit as h tends to 0 of cosine h take away 1 over h, we know is 0. So this is sine x times 0. And we know that the limit as h tends to 0 of sine h over h is 1. And so we just get left with sine x times 0, which is 0, plus cosine x times 1. So just cosine, whoops Daisy, let's try again, cosine of x. Okay, and we are done. This is question number 13. On a roller coaster ride, passengers travel in carriages around a track. On the ride, carriages complete multiple circuits of the track such that the maximum vertical height of a carriage above the ground is 60 metres. A carriage starts a circuit at a vertical height of 2 metres above the ground, and the ground is horizontal. The vertical height h meters of a carriage above the ground t seconds after the carriage starts the first circuit is modelled by the equation h equals a take away b t take away 20 all squared, where a and b are positive constants. Find a complete equation for the model. Okay, so we know two things. We know that the maximum vertical height is 60 meters, and we know that it starts at 2 meters above the ground. Okay, so because we've got a quadratic model, okay, if it's got a maximum height of 60, then this quadratic's already in completed square form. So we can read off straight away that a has to be 60, okay? Because if you didn't have a as 60, okay, the idea is that you'd be then 60 take away b t take away 20 all squared, right? So the t take away 20 all squared is positive. B we know to be positive, so you'd just be subtracting a positive value. So a has to be 60. Now, if a is 60, then h is equal to 60 take away b t take away 20 squared. Now we know that when t is 0, b is 2. Sorry, h is 2. So, if when t is 0, h is 2, then 2 is equal to 60 take away b lots of 0 take away 20 squared. Okay, so 2 take away 60 is minus 58, and then we're going to divide that by minus 20 squared, so minus 400. And we get b to be 0.145. So therefore, h is equal to 60 take away 0.145 t take away 20 squared. And that's the model. Part B. Use the model to determine the height of the carriage above the ground when t equals 40. Okay, so when t equals 40, we're going to have 60 take away 0.145 times by 40 take away 20 squared, that's 2. So it's 2 meters. In an alternative model, the vertical height h meters of a carriage above the ground, t seconds after the carriage starts the first circuit, is given by h equals 29 cosine of 9t plus alpha degrees, so in degrees, make sure you calculate in degrees, plus beta, where alpha and beta are constants, and alphas go between 0 and 360. Okay, so find a complete equation for the alternative model. So again, we know that the maximum height is 60. So what you've got here is 29 times cosine of 9t plus alpha. Now, regardless of what the 9t plus alpha is, cosine goes between minus 1 and 1. So 29 times that goes between minus 29 and positive 29. So you're adding on beta to that, and so the maximum that value can get is 60. Okay, so 60 is equal to, now the highest that can be is 29, right? 29 times 1, so 29 plus beta. So beta must be 31. Okay, so what you're saying is the maximum height that it can reach, that's the only way, that's the only beta that can reach up to 60. Okay? So now that we've got that, we also know that when t is 0, h is 2. So when t is 0, h is 2. So 2 is equal to 29 cosine of 9 times 0 plus alpha plus 31. So that means we can isolate cosine of alpha. So 2 take away 31 divided by 29 is minus 1. And the cosine curve is at minus 1 when we're at 180 degrees. So this implies that alpha is 180. So therefore, h equals 29 cosine of 9t plus 180 degrees plus 31. Given that the carriage moves continuously for 2 minutes, part D, give a reason why the alternative model would be more appropriate. Okay, so the time here was in our model, t's in seconds. Okay, so if you're in 2 minutes, there's 120 seconds. So if you were to substitute 120 into the first model, 60 take away 0.145, 120 take away 20 squared, you get minus 1,390, so that'd be meters. So the thing about the second model is that it's periodic. Okay, if you substitute t equals 120 into that, so 29 cosine of 9 times 120 plus 180 plus 31, we get 2. So rather than being minus 1,390 meters, we're at 2 meters, we're back to where we started. Okay? So the second model is periodic, and so models multiple circuits. So when t equals 120 seconds, h equals 2 meters. So the carriage is back to its initial position. Okay. So this is question number 14. Prove, using algebra, that n plus 1 cubed take away n cubed is odd for all natural numbers, n being a natural number. Okay, so n plus 1 cubed take away n cubed. So we can expand the n plus 1 cubed using binomial expansion. So n cubed plus 3n squared plus 3n plus 1. So 1, 3, 3, 1, Pascal's triangle. And we've got take away n cubed on the end. So the n cubeds can go. I'm going to be left with 3n squared plus 3n plus 1. Now the 3n squared plus 3n, we can factorise that, can't we? So if we factor out 3n, and we'll have n plus 1. Okay, so if n is a natural number, then n and n plus 1 are consecutive integers, okay, or consecutive natural numbers. So n plus 1 is the product of two consecutive natural numbers. So one of these must be even, okay? So it's either even times odd or odd times even. Therefore, 3n, n plus 1, must be even, as it has a factor of 2. Therefore, 3n, n plus 1 must be odd for all natural numbers, okay, as required. So this is question number 15, and this is where Edexcel are not being kind to the budding YouTuber in trying to fit everything onto one page. Okay, you've got to make this awkward for me, haven't you? Right, let's crack on. A curve has equation y equals f of x, where f of x is equal to 7x e to the x over the square root of e to the 3x take away 2, where x is greater than the natural logarithm of the cube root of 2. Part A, show that f prime of x is equal to 7e to the x e to the 3x times 2 take away x plus ax plus b over 2 e to the 3x take away 2 to the 3 halves, where a and b are constants to be found. Whew. Right, okay, let's get to some available space. Right, so A. So let's first of all rewrite that equation. So f of x is equal to 7x e to the x over the square root of e to the 3x take away 2. Right. Okay. So we need to differentiate this. We're going to be going straight in with the quotient rule. So f prime of x is equal to, so that is the bottom, so e to the 3x take away 2 to the half times by the derivative of the top, which requires us to use the product rule. So that is 7x times the derivative of e to the x plus e to the x times the derivative of 7x, so 7 e to the x. So far we've done the bottom times the derivative of the top. Then we need to do take away the top. So 7x e to the x times the derivative of the bottom. For that we're going to need to use the chain rule. So the half is going to come down to the front. The derivative of the inside comes outside, which is 3e to the 3x. And then we take 1 from the power. So minus a half. All over the bottom squared. Okay. Right. We've got our work cut out. So, first thing we're going to do is we're going to multiply top and bottom of the fraction by e to the 3x take away 2 to the half. Okay? What that will do, and the reason for doing that, is to get rid of this minus a half power here. So, multiplying top and bottom by e to the 3x take away 2 to the half will get rid of that. It'll simplify my first term as well to e to the 3x take away 2. Okay? Now, let's leave the other bits alone for the moment. 7x e to the x plus 7 e to the x. Then take away. So let's also simplify this, because we've got the 7 times a half times 3, so 21 halves. And we've got an x. You've got e to the x times e to the 3x, so e to the 4x. And the e to the 3x take away 2 to the minus halves now gone. And we've got, now we've multiplied the bottom as well, remember. So e to the 3x take away 2, now to the 3 halves. So it was the power of 1, we've multiplied by e to the 3x take away 2 to the half. 1 plus a half makes the 3 halves. Okay, let's keep going. So the numerator, the 7x e to the x plus 7 e to the x, we can factor out 7 e to the x from there. We've also got that 21 halves. So I think I want to multiply through by 2 to get rid of the fraction. Can we do that in one step? Let's multiply everything through by 2. And let's factor 7e to the x outside of that bracket. So that means we'll have 7e to the x times by 2. So 14 e to the x, e to the 3x take away 2. Now what will we have left? So factoring out the 7e to the x, we'll have x plus 1. Now we've multiplied everything through by 2, remember, so we've got 21 x e to the 4x over 2 lots, because we multiplied top and bottom by 2, e to the 3x take away 2 to the 3 halves. Not sure if I like. There we go. Okay. Right, looking better by the minute. Okay, so now that numerator has a common factor of 7 and has a common factor of e to the x. So let's factor out 7, whoopsie daisy, 7 e to the x, and we'll have 2 lots of e to the 3x take away 2, x plus 1, then take away, so we factored out the 7e to the x, so that's 3x e to the 3x, and our denominator is still 2 e to the 3x take away 2 to the 3 halves. Okay. Slowly but surely. Right, we're going to need to multiply out this bracket. So, we've got 2 e to the 3x times x, so 2x e to the 3x. We're going to have e to the 3x times 1, so 2 e to the 3x. We're going to have 2 times minus 2 times x, so minus 4x. And then 2 times minus 2 times 1, so minus 4. And we've still got the 3x e to the 3x there. 2 e to the 3x take away 2 to the 3 halves. Okay, we're almost there, I think. So we've got 7 e to the x. Okay, so we have the 2 e to the 3x. We've got 2x e to the 3x, take away 3x e to the x. So take away x e to the 3x, take away 4x, take away 4, all over 2 e to the 3x, take away 2 to the 3 halves. And finally, let's factor out the e to the 3x from the first 2 terms inside that bracket to get it in the format they want. So e to the 3x, 2 take away x, take away 4x, take away 4, over 2 e to the 3x, take away 2 to the 3 halves. So let's just double check. Is that the format they want? 7 e to the x. E to the 3x, all good. 2 take away x, all good. Plus ax plus b, the denominator's fine, so that means that a was minus 4 and b was minus 4 as well. Lovely. Okay. Back up to the question. So we've got our format done. Part B, hence show that the x-coordinates of the turning points of the curve are solutions of the equation x equals 2e to the 3x take away 4 over e to the 3x plus 4. Right, turning points. So, turning points exist when we're working with f, aren't we? So f prime of x is 0. So, therefore, 7e to the x, e to the 3x, 2 take away x, take away 4x, take away 4, all over 2e to the 3x, take away 2 to the 3 halves, must be equal to 0. Now, the only way a fraction can be 0 is if the numerator is 0, and e to the x can't be 0. So the only way that this can be 0 is if we've got e to the 3x, 2 take away x, take away 4x, take away 4 is 0. So that's as e to the x cannot be 0. Okay, so we need to rearrange this to make x the subject and get all the e's onto the other side. So what I'm going to do is I'm going to multiply out the bracket, so 2e to the 3x, take away x, e to the 3x, take away 4x, take away 4, equals 0. So let's leave the 2e to the 3x and the minus 4 on that side. Move everything else over to the other side. Okay, because that bit we can factorise. We can factorise the right-hand side. Factoring out the x. Okay, and now we can divide through by that bracket. Okay, a little bit. Let me just rewrite that bit. One moment. There we go. So 2e to the 3x, take away 4 over e to the 3x plus 4. Lovely. Right, part C. Right, a student uses the iteration formula xn plus 1 equals 2e to the 3xn, take away 4, over e to the 3xn plus 4, in an attempt to find approximations for alpha and beta. Diagram 1 shows a plot of part of the curve with equation 2e to the 3x, take away 4, over e to the 3x plus 4, and part of the line with equation y equals x. Using diagram 1 on page 42, Part C, draw a staircase diagram to show that the iteration formula starting with x1 is 1 can be used to find an approximation for beta. Right, where is this graph? Aha, okay, here we go. Right, only use the copy of diagram 1 if you need to redraw your answer to part C. Okay, so we're using the x equals g of x method here. We're going to build a staircase diagram. So you start from 1 on the x-axis, and then you go up to the curve first, so vertically to the curve, then horizontally to the line. So starting at 1, we're going to go up to the curve, then horizontally to the line. Okay, curve, line. Didn't do that very well. Let's try again. Curve. Still not doing that very well. It's much harder than I thought it was going to be. Then line, and so on and so forth. Okay? So, this point down here would be your x2, and then this point here would be your x3, and so on. Okay? So, demonstrating that you are homing in on that route. Okay. Right, use the iteration formula with x1 equals 1 to find to 3 decimal places the value of x2 and then the value of beta. Okay, so part C, and this is part 1. So we are using x1 as 1. So what we want to do is we want to replace the x's in there with 1. So in your fraction, 2e to the 3 times 1. Actually, let's do this instead. Let's first of all type 1 and press equals. And then, in your fraction, 2e to the power of 3 times the answer key. Take away 4. Over e to the 3 lots of the answer key plus 4. Right. So if we press equals, then x2 is, and we want this to 3 decimal places, 1.502. Okay. Part 2, we wanted to find alpha. So that's the actual root. So let's just keep pressing equals and it will home in. And, beta, not alpha, beta is 1.968. Okay. Right. D. Well, that was D. I mislabeled that. That's D. And E. Here we go. Back on track. Okay. Using a suitable interval and a suitable function that should be stated, show that alpha is 0.432 to 3 decimal places. 0.432. Okay, so we need a suitable function to show that that is a root. So, this is really getting us to use the change of sign method, isn't it? So, we could set that whole of f prime of x to be our function. But we don't really need to. We just need to use the bit that's in the bracket. So if we let's let g of x be e to the 3x, 2 take away x, take away 4x, take away 4. Okay? And we want 0.432 to 3 decimal places. So if it's 0.432 to 3 decimal places, then the lowest that could be is 0.4315. Up to 0.4325. Okay, so we're going to substitute those in. So e to the power of 3 times 0.4315 times 2 take away 0.4315, take away 4 lots of 0.4315, take away 4. Okay, so we're getting minus 0.002275.3. Okay, and if we change it to 4325, we get 0.0072614, etc. So, as there is a change of sign and g of x is continuous, between 0.4315 and 0.4325, then alpha equals 0.432 to 3 decimal places. Okay, and so that confirms that I've got that result, 0.432 to 3 decimal places.